Hello students, it's Mr. Win here. Thanks for joining me. Today I'm going to show you an example of how you can use desmos to solve pretty much any quadratic equation. So let's take this one for example. We have an equation that it's in factor form. So what I'm going to do is I'm going to copy this equation, Control C, and then I'm going to go over to Desmos graphing calculator. I'm going to paste that equation in there. Notice Desmos will graph any equations in any form. So that's the nice thing about this, right? So we're not going to only talk just about the solutions of this equation, but every other aspect of this equation could be found on the graph if you were to use Desmos. So here's another nice thing. In Desmos, you can manipulate your graph pretty fairly easily, right? Move it up, move it down, make it larger, make it smaller, so you can see all the characteristics of this parabola, right? So for this particular equation, you can see that the x-intercepts are right here. If you would just hover your mouse over it and click right there, it will tell you where the x-intercept is. Now, I'm not being very accurate, but if you look at the order pair, it looks like it's -1, 0, right? So if you were to just type that in here, -1, 0, comma 0, uh, and it will pinpoint right there where the solution is. You could actually label it too if you want, right? And then if you hover to the right side of your quadratic graph or your parabola and hover over this, you can see the other order pair is 3, 0, right? So I'm going to go ahead and label that one as well. 3, comma 0. So here you go. These are actually your solution, right? So I'm going to label it root 1, right? And I'm going to label this root 2, right? Now, if you want to, you can put the order pair in there. I don't know why I put parentheses around them. Root 2. If you want to, you can put the order pair 3, comma 0 as your label, right? And for root 1, you could also put the order pair -1, comma 0. Okay, and another feature of the parabola is the vertex. So on Desmos, you could actually find the vertex fairly easily as well, right? So if you hover your mouse over here, you can see the order pair is 1, -8, right? So just like before, I'm going to go ahead and label it 1, comma -8, and then I'm going to label it vertex, right? Vertex. So I'm going to type in the word vertex 1 comma -8. Okay, there's my graph right there. Now if you notice the vertex, if you remember, vertex gives you two things. Vertex gives you the axis of symmetry, which is a vertical line that cuts this parabola into um, um, the left and the right, so it's called the axis of symmetry, right? It's And then it gives you the minimum or the maximum. In this case, it's a minimum of -8 right here. So you could actually also graph those lines. Okay, so for vertical line, we're gonna graph x equals 1, right? So there's your axis of symmetry. Now you could also go to setting, and you can make that line dotted if you want. You can dot it the line, okay? You could dot it this way, and you could make it even a different color if you want. So let's make it blue or violet. It doesn't matter, okay? You hit done. There's your axis of symmetry, okay? And then for the minimum is y equals to -8. You could also type that in here, y equals -8, and it will graph that minimum line for you. Like before, you can go to setting, and then you can click on that color and change it to green and maybe make it dotted, okay? And then there's your minimum, okay? So what do we have so far? We have a quadratic equation that gives a parabola that opens up. And the reason it's open up because this 2 right here is positive, right? If it was negative, it would have been opening down. It gives us the two roots, which are the solutions or better known as x-intercepts in this case because we have a graph, right? So the x-intercepts in this case are your solutions, which is -1 and 3. Using desmos, you could also easily identify the vertex, which is 1 comma -8. The vertex gives you the axis of symmetry, which is x equals to 1, and it gives you the minimum in this case, which is y equals -8. You could find these things fairly quickly and easily if you use desmos to graph your quadratic equation. Um, there's another thing. I mean, not a lot of people would pay attention, but one of the characteristics of any graph is the y-intercept, right? So if you hover over here, it's the y-intercept right here. You could actually label that as well. So if you put 0, -6 in here, 0, comma, -6, and then you go down to label. Now let me close this one out. If you go down to label and you put y intercept, and you could put the order pair if you want, 0 comma -6, so you can identify it fast. I didn't type 0, so here we go, 0 -6. Okay, so y-intercept, x-intercept, axis of symmetry, minimum. Okay, what else can we get out of this graph? Well, if you look carefully, if you graph your minimum or your maximum, you can actually tell where the domain is, right? Or the range is, right? So the domain for any quadratic function is -infinity to +infinity because it travels from left to right infinitely. That means we don't know where it's going to stop, right? But the range, though, it begins at -8 on the bottom and it travels to the top infinitely. So the range would be from -8 to +infinity. So if you were to write it, you would write it like this: -8 to +infinity. I don't know if I can type infinity in here, but it's the infinity symbol. I don't think I can type it in here, so I'm not gonna type it in. Okay, but anyway, that's what you can do with Desmos, and I hope you join me next time on a different example. Thank you for watching, guys. See you later. Bye bye.